All right, so actually let's first look at the video. There it is. Okay, so first I love that you did the IKFK with letters and over the arm. I also like that you experiment with the font. So the IK arm is working and the pull vector is working. And then it switches to FK. This is great. So everything but the rotation is locked. That's also great. And then both FK controllers look like they're working. Okay, so the demo is great. It shows all the parts of the IKFK rig and shows that the setup is working. Okay, so the first thing I check is how clean are the joints after this setup. So there are no rotation values on the IK, but I noticed there's some rotation values on the FK joints. So it looks like they got created when maybe when you were duplicating or when you duplicated and started creating constraints. So there could be multiple chances for them to get created. But the cleanest way to remove them is to just remove those connections, zero them out, check that all the orientation matches, and then recreate those constraints. And that's oftentimes with rigging to fix something, you kind of have to redo that. Okay, so now let's keep checking. So the IK controls, so this is the pull vector. So since IK is zeroed out, that means the pull vector is correct. So one note about the mesh of the robot. So it's good that you made it a little bit angled. That makes it easier for placement of joints for IK chain. When you're doing that, it makes more sense to keep it to keep the wrist going the same direction as the elbow. So like so, right? So this would be the wrist. So to follow this elbow line. But yeah, but for this assignment and for this model too, it doesn't matter that much. It's more for the future. Okay, now let's switch to, so let's check first that all the controllers are zeroed out. That's great. So now let's switch to FK. So there's a bit of a flip happening, sorry, a bit of a shift happening. So that's something you want to avoid. So it looks like maybe the orientation of the last joint shifts. It's hard to tell. And the way, let's see, so yeah, oh yes, there's some rotations I see on here, which means, yeah, so I think that's actually related to these rotations here, and then there are some rotations on the elbow. I mean, these are so minor, they probably wouldn't make a difference, but I think it's probably related to that. So yeah, so again, the best way to fix that is just to take it apart and build it from ground up. Okay, so yeah, so some minor issues, but overall it's working well. Okay, any questions? No. All right, let's move to Shantae's rig. So first, let's actually look at the video. All right, so first of all, I like that you tried doing it, that you did it for both arms. So that's great. And I like that you place the IK, that you made IK-FK controllers with letters. That's also great and good practice for us. One thing, I wouldn't place them on the ground. So when they're placed like so, it's more difficult for Animator to reach it in order to switch the mode. So when it's above the arm, it's kind of easier to reach.
Okay.
All right, so the IK controller. So again, it's great. You're only keeping the attributes that you need. Switching to FK. Okay, that's working. And then switching back to IK. Great. So now the left arm. Okay, rotating that. Now FK mode. Okay. And now switch to IK. Great. Yeah, again, demo is good. And it shows that the setup is working.
Okay.
So let's take a look at the file. So my first note here would be again about the geometry placement. So I think it's good that you changed the elbow to have a bit of an angle. But usually when you do that, you want to still keep the arm kind of leveled and kind of perpendicular to the body. So you would usually, if you need to create an angle, you would do it kind of like this, right? So you would put the elbow here, but you would keep the wrist over here, and it can still be pointing the same direction. But you don't want to kind of make, because this way the character is almost like it's posed already because it has arms pushed like that. This way it's still in the default relaxed position if you're to do it this way. Okay. So that's that. So now let's check. Yeah, so there are some rotation values on the IK joints. So it looks like the position of the pole vector is not quite right. So just as a reminder, when you're placing the pole vector, you can create a mesh using this create polygon. Switch to normals and take it out, because if you do that, you will get this kind of triangle, and then once you take it out, it will be kind of on this line. Okay. If you have your joints positioned like that, the pole vector will probably be somewhere here. All right. Yeah, and I also like that both you and Sophia, that you guys tried doing like other controller shapes. So both this IK-FK controller and the cubes for IK mode. So that's a great way to distinguish between IK and FK. And here I also like that you kind of change the colors for IK and FK, and they kind of match the colors of the mode. Yeah, I think that's a very nice touch. All right. So now let's switch to FK. Okay, so that's also great that all the attributes here are locked. Let me switch the layout. There we go. Okay, so that's working. So this is good. So let's see. So the FK control, so FK joints are fine. So these don't have any values. So these are set up well. And it's really good that you did it for both arms. The more practice you have with this, the kind of the better you get. So that's great too. All right, so for this arm, looks like so you still have some values here. Yeah, And so because this controller is still not in the same plane here. Okay, let's check. But so this is working. This setup is working fine too. Okay, great. So yes, overall good. Just so the only issue is with the placement of the pole vector.
Okay.
Any questions?
No, I think I'm good.
Okay, great. Okay, so now, Tatiana, do you have a Maya file that we can look at?
Yes, of course. I put it there.
Oh,
Isn't it in the school?
I don't see it uploaded.
Oh my God. Just a moment. What's it in B?
Okay, well, let's look at the video first.
Okay. It's very strange.
Okay, well, I like that also that you have IK, FK, and that you even place them in the circles. That's great. And also, so the difference between controllers that in IK, they're in this cube shape. That's great too. Okay, they're working in IK. Now switch to FK. That's good. Okay, it looks like FK is working well too. Yeah, so I think all of you did a really good job on this. I would just lock the, it looks like these attributes are not locked and hidden, so it looks like you just missed
I just forgot,
one
I think.
controller here.
I just, yeah, I forgot, I think, when I was making the video.
Right, yeah.
My file. How to make this window smaller in Zoom? Do you know?
Which one?
The Zoom one. The program.
I think you can minimize it just as any other one.
Just cannot I see.
Like with the minimize button?
Somehow it doesn't work.
You can also upload it after the class, and then
I want you to look.
Yeah. Oh, okay.
Maybe I don't know. I cannot move it somehow. It's stuck on my. I have two monitors now after this assignment. So I had to buy another monitor because one was not enough. And I have some questions about joint orientation and everything. So maybe I can just go out of the conference and then come back again.
Okay, yeah, that works.
It will, yeah, it will take just a few moments. Okay, thank you. Yeah.
All right. And for now, we can, while we wait, we can look at the image. Okay, so that's great. This shows all the connections. Okay, and Shante, I forgot if I asked, did you have any questions about the assignment? Is Shante here? Maybe not. Okay, actually, I'll take this time to get my notes. So I'll go off for a second as well.
Hello, is there anybody out there?
She went to grab her notes real quick. She'll be back in a sec.
Oh, it's cool.
Okay.
Yeah, I'm
Everyone's
here.
back.
Yeah.
All right. So did you have a chance to upload?
Yeah, it must be there.
Nice. Let's take a look. All right, great. Yeah, and for this class, binary files usually work better, just because they're smaller, so it's easier for me to download. So for all of you, when you're saving, you can save as either one, but when uploading, it's better to save as a binary file. Okay, let's take a look here. Yeah, so the same note as for Shantae. It's better to have the arm be lined up so that the shoulder and the wrist are on the same line.
Mm-hmm.
So like so. Okay. How do I get that clear? Okay, now let's take a look at the setup. Yeah, and for all of you have a very nice clean outline, and in this case too, this is very well set up. That there is a group for right arm, group for left arm, and then there are separate groups for IK and FK. Okay. Yeah. So one thing you can also do is have different groups for joints and controllers. So that's a way to organize it as well. Okay, so there are no values on IK joints. That's great. No values on FK joints. That's also great. Let's now switch to IK. Actually, let's try doing it with both controllers. So that's good too. So sometimes when working on both sides, you can make a mistake of naming them slightly different, of naming the attributes slightly different. And then the animator can't switch the two attributes together. So in this case, you did it right. You named them the same. So now we can switch from IK to FK on both arms together. So that's great. And the placement of this controller is also good. All right. So now let's. Okay, so we were in FK mode, so now we're in IK mode. So this looks good. Check it in FK mode. So yes, I already made a note about that controller. Okay, these arms are working fine in all directions. Let's try rotating them. Yeah, that's good. So since this is a rigid model, you can just assign, you can either parent or bind this whole mesh to the joint, because right now it kind of behaves as if it's a soft body, and there is no need for that in this case. But obviously for this assignment it doesn't matter because that wasn't part of it. All I care is the IK-FK setup. Okay, any questions?
Yeah, sometimes when we use different menus like orient constraint or some others, there are two different buttons, add and apply. And I sometimes confused which one to switch, add or apply or add.
Yeah, the only difference is that when you click add, it closes the menu. When you hit apply, it keeps it open. That's the only thing it is. Other than that, they do completely the same thing.
Yeah, and X orientation. So is it important? I thought it should go for always from shoulder to the wrist, no? Because in the second arm, I have this arm is all right, but the second arm, I have X orientation to the body of the robot, and I think it is not right.
No, that's completely fine. So when you're doing mirroring by behavior, that is supposed to happen, right? Because otherwise, if it's going towards the child, then it will rotate as this joint should rotate, but it actually should rotate as if it's a mirror of the previous one. So your joints on the other side, let's take a look at them. So this one looks like it was your main
original one, yes.
And this one, so this one, the X is pointing not towards the child, but it's pointing to the opposite of that direction, which is exactly correct. So what that allows you to do is to have this kind of behavior, right? So that both arms can be rotated together.
And I want you to check the elbow rotation or elbow orientation of X on this second arm.
On this one, right?
Yes, yes, because I didn't like the way it is oriented, but I tried to fix it, and I affected the child, and it was a complete mess. So I left it the way it is because I didn't see the different. I like the rotation and the working of the arms, but I'm not sure that it is the right stuff.
Okay, let's take a look. So
It
this
must
is
be
the
L.
right
Must be
one.
this the right? Yes.
Okay, let's hide this one. So this is the one we care about.
Yeah.
Yeah, it looks correct to me. No, looks fine to me. No, it doesn't look off.
So this X, you see, this X
Yeah.
line, it should be aligned with the child, yes?
No, it shouldn't. So since you mirrored it, it doesn't have to be. So it should just be the opposite of this. Right?
I see. So if the first one was right, it is okay if it looks a bit like off the course.
Yeah, and I'm saying the opposite of this joint. It's actually the same as this joint, right? It points the same direction, and that's why they behave in the manner that makes more sense.
Okay, and I wanted to ask about rotation values. If there is -0, does it affect anything? It should be clean without any minuses?
No, minus is fine. So that's something that happens sometimes with minus calculations. It sometimes puts this minus there, but it actually doesn't matter. It's just like, I wouldn't even call it a bug that they have. It's just a peculiarity that they have, but it's the same as just having 0.
So we can leave it like this, yes?
Yeah.
Make it -0. Oh, okay. Yeah, I believe that's it.
All right, great. Well, yeah, great job. And thanks for all the questions. All right, now let's move to today's lecture. So, yeah, so first note is that you noticed that the assignment is not quite the same as what we did for the homework. So that's because I think when preparing, I looked at the old syllabus, and the assignment for week 3 was this IK-FK switch for the arm. Then it changed to the pendulum clock. And now I took a look at the pendulum clock, and I actually really liked this assignment. So maybe later on in the course, we'll do the pendulum during the arm rigging week, but we'll see. Okay, but so for today, we're going to talk about skinning. So first, we just discussed kind of the hierarchy. So first, you assembled the hierarchy of the robot, and you could see that already you could get some nice movement. Then we took a look at joints and how you can create already an IK chain with joints. So now we will take a look at how you can use joints in order to skin your geometry. If you remember last time, we talked about how we have joints in the characters that have soft body deformations, right? So for example, the Malcolm rig, it has joints because it's a human character and it consists of one mesh. So we can't just separate different parts of the body, right? Okay, so now let's create just a very simple mesh, a cylinder. Let's increase some subdivisions. Okay, and now we can create a very simple rig. So it will be just 2 joints. Also, something I don't think I mentioned. So joints have this radius attribute that you can change in order to make them bigger or smaller. So that can be pretty handy. You can also change the radius of all the joints, so how all the joints appear, by going into your preferences, going to, so going to here to kinematics, and changing the joint size. So if you want to make them slightly bigger or slightly smaller, you can adjust this slider here. So remember how we discussed that joints don't have a shape. So that's because they're not actual physical objects the same way as polygons are in Maya. So that's why we can just change the appearance of all the joints in the scene and not change how they act or anything about them. So we do that through that preferences setting. All right, so now what I'm going to do is I'll unparent this child joint from the parents, and now there are just 2 separate joints that I can move around. So right now, these joints and this geometry are not in any way connected to each other. They just they're just positioned in the scene by themselves. So one way to connect them is to parent them, but with a joint, if we are to parent it, then we can only parent it to one of the joints. So in order to have both of these joints control this geometry, we want to bind them to those joints. And that's what skinning, that's the first step of skinning. We want to bind the geometry. Okay, so the way we do that, we want to select the joints, then the geometry. We can do it the other way around too, doesn't matter. Then go to skin, bind skin. And I clicked on the option box here. So the first option you have is bind to. So here we can select whether we bind to the joints that we selected or we bind to the joint hierarchy. So if all of our joints are in the same hierarchy, so for example, if it's a chain of joints and all the joints are connected to the root, then we can only select the root joint, select joint hierarchy, and that will skin our geometry to all the joints. In our case, we have 2 separate joints, so we want to click selected joints. Now, bind method, we can choose between closest distance, closest hierarchy, heat map, and the voxel method. So it doesn't really matter that much which one you choose. You kind of want to play around with them and see what works for different cases. So closest distance, so now in case they're not in the hierarchy, so the second option wouldn't work. Heat map wouldn't really work because we don't have a map, so closest distance will work fine. So now skinning method. So for the longest time, Maya had just one option for this, so it was always linear. Oh no, sorry, I'm thinking of the weight normalization. So skinning method, so that's about how kind of the weights change. So they can change in a linear manner, or they can change in these two different manners. So again, this is not very important because we usually change all of that anyway once we start doing the actual weight painting, and the classic linear has always worked well for me. Yeah, so now normalized weights. So for the longest time, it wasn't an option, and weight normalization was always interactive. So what that means is that, so by default, certain weight is assigned to vertices, and if weights are normalized, so if normalized weights is interactive, it means we can't assign a value of more than 1 to a vertex. So it can't go more than 100%. And with post, it means that it actually can while we're skinning. So post was, again, post and none were the later options, and I think they make it way more difficult to weight. So it's a good idea that you don't have to think about values as much. You can assign more value than 1, but it actually hurts you in the long run because then your default pose might have a change in the way the vertices behave. So interactive is a good option here. Again, weight distribution, since right now our joints are not parented to each other, distance will work well. Allow multiple bind poses we always want on, because there's no reason why we don't want to allow them. However, if you find yourself that you're often troubleshooting and you don't have and you can't get to your original bind pose, you can try turning it off and see if that helps you. Now, influences. So what influence means is just what is influencing the mesh. So in our case, it's joints. And by default, it will try to assign a certain amount of those influences to each vertex. And in our case, we only have 2, so we can put anything bigger than 2. Oops, it won't matter. So now this option, maintain max influences, we don't want it to be on, right? Because what that will mean is that we can only have, say, 2 joints per vertex and no more, but then we might add another joint or something. So this one I always keep off. Also, we don't want to remove, I at least never want to remove unused influences, because by default, Maya might not assign some weight to an influence and then it will remove it. So since I always know which joints I'm adding, I don't want them to be suddenly removed. Then colorize skeleton, you can turn it on and see how you like working with the skeleton when the colors changed. I usually keep it off because it's a bit distracting for me when weight painting. And then include hidden selections on creation. To be honest, I never use this option. It's kind of recent, and I'm not sure what exactly it does. And then the drop-off rate is about how the weights are changing in between different vertices. Okay, so this was kind of a lot of description of all these things. If it didn't make much sense, I'm sure it will make sense as you kind of try it for yourself. Okay, so now we just click bind skin. And again, the same as with constraints, you can hit apply or bind skin. If you click bind skin, it will just close this menu. If you hit apply, it won't. Okay, so we're clicking bind skin. And now, if we move around the joints, it will move the mesh with them. So how Maya is doing it and what's happening here is that when we are binding the skin, each vertex gets a certain value of how much it should be following each influence. So and by default, Maya just approximates what those values should be. And it works kind of similar to parenting or constraining in a way, but it's just that each vertex is in some way parented to this or this joint, or maybe in some ways constrained. So this vertex, for example, is to some amount connected to this joint and to some amount to this joint. So it could be, for example, that it follows this joint with the value of 0.8 and follows this joint with the value of 0.2. So since we're normalizing weights, they should always add up to 1. So it follows this joint by 80% and this joint by 20%. That's what it means. So it's almost like how we change the weights of the constraint. So this is something very similar to that. So it's as if this vertex is constrained to 2 of these joints, but by different, but has different weight value. Okay. So now if we want to check what those values are, we can go to component editor. So that's in general editors, component editor. And in here, you will find smooth skins. So there's a tab called smooth skins. And if we click on any vertex, you can see it tells us how much it's weighted to joint 1 and how much it's weighted to joint 2. The more joints we have, obviously, the more values it will show us. And so you can see joint 1 is this one, so it follows it by 0.038. And this joint is joint 2, so it follows it by 0.962. Now, if we are to choose this vertex, you can see it follows joint 2, this one, by 1, so by 100%, and it doesn't follow this joint at all. So if we are to move this joint, you will see it. So this vertex is not changing its position at all when we move this joint, so it stays exactly where our top joint is. And you can see these joints are following just slightly. And then this joint at the this vertex at the very bottom, it follows it by 100%, right? So if we are to select it and check what its values are, it's the opposite of the top vertex. So it follows this joint 1, 100%, so with value 1, and it doesn't follow joint 2 at all. Okay. So with component editor, we can also change that weight. So let's, for example, see what the weight is here. So these vertices are weighted exactly half to this joint 1 and joint 2. And that's why when we move them, when we move the joints, they go exactly in between. So what we can do here is we can change that. So we can, for example, make them follow joint 1 by, let's select all of them. So I'm selecting all of them. Wait, there we go. I'm selecting all of them and I'm changing it to say 0.8. So you can see automatically it changes the weight of joint 2 to 0.2. And the result it gives us is that when we move around this top joint, they don't follow as much anymore. So this ring of vertices doesn't go in the middle. It kind of favors the second joint. So when we move it around, you can see this middle ring, it follows the bottom joint much more than it follows the top one. Okay, that makes sense? All right. Now, changing, so we could just change the weights all the time in a component editor, but that gets kind of tedious, right? Because we have to change those values sometimes per each vertex. And it's not very intuitive to do that through the component editor. So what we can also do is use a tool that Maya provides, which is under Skin. Then you can see Paint Skin Weights and the option box. And so this allows us to paint the weights in a much more, in a much easier way. And you can see that it's kind of similar if you use Maya's modeling tools, so the one, the sculpting tool. So you can see it's kind of a similar layout, right? So you have some kind of brushes and some kind of options here. So this is another way of assigning those values. So in here, in this window above, we can choose which influence we're going to use. So we can choose either joint 1 or joint 2. So that will make that influence selected. And it will also, with this color scheme, it will show us how much weight is assigned to each vertex from this influence. So if we're selecting joint 2, you can see at the top, it's all white, which means 100% of the weight is assigned to this vertex. You can see here, it's red, which means that also a lot of weight is assigned here. Then it gets kind of green and then blue. So if the colors, if you forget what the colors mean, you can check here. And you can also check or uncheck this use color ramp in order to use either grayscale or the color definition. So if we uncheck it, you can see it's all just goes from white to black. So black means 0%, doesn't affect it at all. And white means that this vertex is following this joint 100%. So since with grayscale, it's often not as easy to see what's going on, I always prefer to use a color ramp. And you can change it too. You can change the way these values are. But I usually keep them by default so that it's easier to see when, say, I'm versioning up Maya. I know that the default is exactly what I'm used to. And you can also change the presets if you want to use different ones. Okay. So now, so first, the way the joints are positioned here, we can position them by hierarchy, which is usually the best way to look at them. When you have joints parented to one another, it will show them kind of the same way as in the outliner. We can also just look at them alphabetically. And in this case, by hierarchy or alphabetically will give us the same result. But once you have more influences, you will see, oops, what happened there? You will see it change. Okay, so now by default, we are in paint mode. And I think by default, it goes to this replace option. So if we're to select, for instance, joint 2, and we're to select value of 1, we can now just paint this value on the mesh. And what this means is that we assigned the value of 1 to all these vertices. Now we can change that. We can assign, for example, the value of 0.5 to these vertices. And again, we can just paint them as if we're painting a texture. Right, so now, if we're going to try moving this joint around, you can see this ring of vertices goes exactly in the middle. Okay, And because we have only 2 joints, the replace option works, because if, say, right now we painted the value of 0.5 and assigned it to joint 2, and since it only had 2 joints, it knew that the only way to normalize weights is to take that value away from joint 2 and give it, from joint 1 and give it to joint 2. So now the weight is distributed between 2 joints. However, if you have more influences, then it might give that weight to joint that you didn't expect it to. So that's why this replace option can sometimes be dangerous. You sometimes might accidentally add a value to a joint you weren't going to. So that's why add here is a better option to use. So now we can, for example, add the value of 0.5 here to, say, these vertices. And what that will do is that they will follow this joint, again, 100%, whereas these will keep the 0.5. Okay. Now, also, when you're doing weight painting, one thing you can do is set a keyframe, say here and here. And now, when you're weight painting, you can be at a certain pose, and you will see how your changes to the weighting will change the way the vertices move. So in this case, for example, we can change something like 0.1 and start adding to these vertices, and you can see they're slowly going up as we're adding that value. Here we're adding that value. Now we might say just 0.1, a bit larger value. And again, this value gets added, and we can see how it changes this deformation. Like so. Now, smooth is another useful option. And what it does, it gives us an ability to smooth in between multiple joints. So let's add back a value of 1 to these vertices. And let's add a value of 1 here as well. So now we have very clear definitions. So all of these vertices are being controlled by this joint, and all of these vertices are being controlled by this joint. But what we can do is we can hit smooth, and we can smooth in between them. So now they're going to be, that value is going to be in between the two. So again, now if we're trying to move them, you'll see it can change that value. So since we were using the brush, it didn't give us an exact in between. But here we can smooth it out as much as we want, right? And we can smooth out here a bit more than we're smoothing out here. So that's the great thing about using the brush, is that we can kind of paint it as we would paint a texture. And for this kind of work, if you're going to do it a lot, it's pretty useful to have a tablet. Then it's easier to assign those values in kind of easier strokes and actually feel like you're painting them on the mesh. Now, in case you have two joints, again, both replace and smooth, for Maya makes sense because it knows which joints to assign the other value to. So it knows here that it needs to smooth in between different joints. Now, let's say we want to add an extra influence here. this joint 3. Let's place it somewhere here. So if we want to add an influence after we already created skinning, we can do that. So we want to select the influence, select the mesh, and then we can go to skin, edit influences, add influence, and it's in the option box. We want to use geometry, so these values don't matter much because I usually set the default weight to 0 so that it doesn't change the weighting that we already did. And also, well, with this option, you'll see what it means in a bit, lock weights. So that basically means that we can't change it once we start using it, but we can unlock it. Okay, so let's add it in. And now in the paint skinned weight, you can see it added this joint 3, and you can see right now it's locked. So to unlock it, we want to press on this icon to the left of it. And that goes, the same goes for all joints. So with all influences, we can lock and unlock them. So if the joint is locked, what that means is that we can't add any more values to it. So even if we try adding values here to joint 1, if I switch between them, oh, I guess we can add in this way. Okay, apologies. So we can, I guess, add the value, but we can't. So if, say, we want to replace now the value from joint 2, say we want to replace this with 0. So now it won't go to joint 1 anymore. Actually, now it did. Yes, this is odd. So usually it's supposed to only go to joint 3. I'm not sure why it now went to the joint that we had locked. Well, I guess that goes to show that this feature is not very reliable. Okay, let's now paint this by 1. What if we now lock this one and try replacing this with 0? Will joint 3 get any value? No, joint 3 didn't get any value. I think it happened that way because, so this is kind of the correct behavior, right? So only joint 1 gets this value, but joint 3 doesn't because it was locked. I think previously it didn't work because this is an added influence. So it must be a bug they have when there's just 2 joints. I think it's not a very common situation where you just have 3 joints like this. Okay, so let's try this again, actually. So let's take joint 2, let's replace this value with 0. Yeah, so now it behaves correctly. So now joint 1 didn't get this value, but joint 3 did. And so now I replaced this with 0. Now joint 2 got this value, but joint 1 didn't. So if you lock all the joints, but the 2 that you're working with, you can use replace if you want. So like so. And the same goes for smooth. So if right now we want to smooth this area, we can do that because one of the joints is locked. So it will be smoothed just between these 2 joints, joint 3 and joint 2. And we can continue smoothing this part here and here. And now what this gives us is this kind of behavior. So now these values are smoothed out, but just between these two joints. Okay, and since this value is assigned to 100% to joint 1, neither joint 2 nor joint 3 will get that value even if we're smoothing it, right? So even if we smooth it, it will change the value here, but as soon as we switch it, you will see it's back to being 0. And even if we had to try to replace it here, it will still keep it at joint 1 as being 1 here. Okay, any questions at this point? All make sense? Okay. Let me take a look at my note to make sure we're not forgetting anything. Ah, right. Another mode. So there's also, so far we've been looking at paint mode. There's also a select mode. So this is quite useful if you want to assign a specific value or add a value to some specific vertices. So in this case, we can select a group of vertices. So for this case, it might be useful to hide the joints so that you don't accidentally select them. So you can select the vertices. And now, so one thing you can do is you can just change the value here. So for example, we can change it to 1, to be assigned to 1 to joint 2. Now if we go to paint mode, you can see joint 2 is controlling all of these vertices, and joint 1 and joint 3 isn't controlling any. So now we can go select these vertices and assign their value to joint 1. So one way to do that would be through changing this value. Another way would be to go to paint mode and hit flood here. So flood means to assign all the value to those joints. So if so this can be pretty useful when we have selected joints and we want to assign a specific value to them. Okay. And then paint select just allows us to select things by painting them, which also can be pretty useful, but I never use it. I just go to select and I select the vertices that I need. Okay, yeah, here you can change the type of brush you're using. I prefer using this kind of hard edged one so to get more precise values for the vertex weight, but you can experiment with different ones, see if something else works better for you. Okay, yeah, so now there are also, you can see some features here. So they can be pretty handy as well. So the icons kind of explain well what they are. So this one copies, this one pastes, and this one averages the value in between something. So if, say, we want to copy all the way from this vertex to this vertex, we can click this copy icon, then we can select this vertex, hit paste, and it will get all of these values. So now it follows this joint with the value of 1. And now if we want to average, for example, this vertex in between these two, we can click this button and it will position it here. So again, these features can be very handy, but they can be kind of dangerous because we don't know which exact joints are we using when we're averaging out the values. Or well, with copy paste we know, but with averaging out the values we might not know which other influences it may use. Okay, any questions about any of these? No? Okay.
No. We are now working with separate joints, and if they are in a hierarchy,
Yeah, it's the same thing. So in this case, it's just easier to show on separate joints, but if they're in the hierarchy, you'll just see them shown differently. Let's say all of these are in the hierarchy. You'll just see them shown differently in here. So here they're positioned in the hierarchy, same way as in the outliner. What that means here is that they're just parented to each other, right? So now we can still move them around the same way. That answers your question? Okay. Anything else? No, all right. So now let's look at blend shapes. So blend shapes are a pretty handy feature. It's a deformer in Maya that allows us to get a delta between two different shapes. So in other software, you might see them being called morph targets. So these days, I sometimes use Unreal for work, Unreal Engine. So in Unreal, they're called morph targets. So, and I think in Blender, they're called the same way. So that's, so you might hear that word too, if you're using other software. So let's create, what happened here? Go, let's create a few pieces of geometry. Okay, let's say they're changed slightly. So now this cube looks like so, and this one looks a bit differently. So sometimes it's useful to have a way to blend in between these two shapes. And the way we can achieve that is by using blend shapes. So to use them, we want to select these target shapes, then select our original shape and go to deform, and then blend shape will be the first option. So you can choose option box and create blend shapes through this. So we want to pick a name for the blend shape node. Let's call it test. Blend shape. Go. Now, in the advanced, you will see there's also deformation order. So we'll look at that later because it matters if we are applying a blend shape on top of the rig. Okay, so we can create test blend shape, create, and now what it does, it creates a separate node. So if we're to look in the node editor, you will see that it created this test blend shape node. And this node has three attributes. Envelope, which just means if we want to turn it off or on. And then these two attributes are the same as the names of the mesh that we connected to it. And if we're now to change these values, it will change to be like the geometry that we have. So this can be pretty handy if you want to morph something from one shape into another. And so you can access them here through this test, if you can find this blend shape node. Another way you can access them is if you select your original geometry and you go to your inputs, you will see that one of the inputs will be this blend shape. So we can change the values here. So we can change this to 0 and this to 1, for instance. And we can combine different blend shapes too. So in our case, it won't change much because it's kind of just these two shapes are the opposite of one another. But in other cases, it can be pretty handy. Now, another way to access them would be through the tool. that Maya provides for working with blend shapes. And you can access it through Windows, Animation Editor, Shape Editor. And then there's also Pose Editor for corrective blend shapes. We might look at it later in this course. Okay, so if you click on Shape Editor, you'll see you have these sliders, which are exactly the same as these attributes. So you can turn these off or on. So one handy thing here is that you can edit your shapes as well. So we can turn it up to be like Cube 2. Now we can go into edit mode and we can edit the shape on this geometry. We don't have to edit it here, right? So if we are to edit it, you will see changes the geometry from which we create the blend shape as well. So then once we finish editing, we can get out of this mode. And now if we're to change the shape, oh, we actually can't because it's being driven by a blend shape. Okay, oh, what happened here? This I'm not sure. Why is it acting this way? Let's see. Okay, let's get out of the edit mode. Okay, this is correct. Now inside the edit mode, grab these two, move them down. Let's go out of the edit mode. Okay, yeah, no, this is correct. I'm not sure why it acted like that before. And maybe because I tried moving the vertices while I had the blend shape on. Okay, so this is the way you can edit the blend shape. You can also, this is pretty handy because you can also delete the blend shapes you have and they will still work because that information, so it stores the delta of that value of the difference between joint position, vertex position. So even if you delete it, you can still see the shape change. Okay, any questions about blend shapes? No?
Do they interact with anything?
Do they interact with anything? What do you mean?
The joints or constraints, or like if you have a blend shape set up on a mesh and then you have it all rigged some other way, does changing the blend shape screw with your like pre-existing rig in any way?
Good question. So if you do it well, it shouldn't screw with it, it should enhance it. So we'll take a look at how you can use the blend shapes in the rig itself in a moment. But the idea is that you would usually rig your character first, and then you can add the blend shapes on top. So for example, a lot of times you first create the rig for the body, and sometimes you will just use blend shapes for your face rig. So you will like add the smile, the frown, and so on. And sometimes you will also create corrective shapes. So say if some kind of movement doesn't look quite right, you can add the corrective blend shapes on top to make it look nicer in that pose. And oftentimes for both just blend shapes or corrective blend shapes, it will be a modeler who's going to be creating that. So I think that's why it can be pretty interesting for you guys. Okay, another blend shape feature that is good to know is that you can paint the weights of the blend shape, kind of similar to how you're painting the weights for joints, but way easier. So you can go to, again, to the form, and then here under paint weights, you will see another blend shape option. So here if we go to option box, you can see it gives you options to paint on either of these blend shapes or on the whole, or on all of them. So if now we are to select, for example, the thing is that painting on separate ones sometimes doesn't work. It's been a bug that Maya had forever. So let's see if it will work now. So let's select which one is on P-Cube 2. Let's say we want to paint out this part. So you can see what it does now. So I changed these two to black, which means that that part of blend shape is not going to be affecting this deformation. So only this part will deform. We can also change the value the same way as with painting weights. You can change the value, for example, for 0.5. And now you can see we changed it to be a bit more. So there we go. Now we changed it to 0.7. There we go. So that can be pretty handy, especially if you want to separate the blend shapes. You can create just one shape, but separate, for example, for two in two parts. Okay, any other questions about blend shapes? No? Okay, good. Then let's move to taking a look at how we can use all those principles on a character. So in your materials directory, you will find a rig called worm with joints. So you want to download it. Let's download it. So it's in my downloads. And I think this is it. Yes, worm with joints. Okay, so you will see that you have here both the mesh. So there's a mesh for the worm, these two eyeballs, and the joints along its body. So let's first make sure to change the display of our joints to make them a bit smaller so they fit better. Okay, so now the first thing we want to do is check how these joints are structured. So the kind of the imaginary scenario here is that, say, someone started this rig, they positioned the joints, and you have to go in and actually make it into a functional rig. So right now there are joints. So they start from the root here, they continue upwards, and then there are two joints at the top. There's one for the head and one for the mouth. So the idea here is that the mouth joint can be moved up and down in order to make the mouth open and close. And then these joints are supposed to be used probably with FK, so just with rotation. And so if we're thinking of how we would rig it, there are multiple ways. So we could also make these IK and create just movable controllers on each part. But just FK controllers would be the most simple way to do that. So if we want to create FK controllers for each of the joints, we would want to create first the controller itself, right? Then we can freeze all, then we can group it, and that will be the controller for the bottom joint. And now we can duplicate them and position them throughout the length of the character. Okay. Duplicate this one, no. and I think I didn't snap all of them correctly. So let's put this geometry on the layer. So now we can snap them to the joints better. All right. Same thing with this one. There we go. There and there. Okay, let's double check that all these groups have pivots at the joints. So now we can orient them the same as the joints. In this case, I think all the joints are just pointing straight, but in order to make sure that they are, we can do kind of the same trick that we talked about before. We can do constrain, orient, not maintain offset, and then hit apply. And then this controller will orient to the joint. And as we're, or rather this group will orient to the joint. And then as we're done with that, we can delete the constraint. So in this case, however, I think all of these joints are positioned straight, so there is no real need to constrain to them and then delete the controllers. So what we want to do now is to position all of them in the hierarchy. So we want to parent them to each other. So I'm selecting the group and parenting to each next controller. So this should be familiar to you from doing the FK arm. Okay, so now I have this kind of chain of controllers. So we can select all of these controllers and move them, and you can see they're moving all together in the same direction. So that means they're behaving in the correct way. So now we can constrain the joints to them. Let's go constrain orient. Oh, there it is. So now let's maintain our offset. There we go. Okay, so all of these are constrained, and now we want a controller for, well, so we would probably, we can also add a controller for the head. And, oh, I see. So since the teeth are parented, I guess the idea is to kind of have it like a Muppet character. So this joint would be moved around, and this one would be moved around too. So we want 2 extra controllers. And for these cases, we can create a cube controller to show that those parts can be moved. Or we can create another circle controller and just shape it to kind of go around the jaw and go around, and also go around the top part to kind of shape them a bit. So just for speed purposes here, I'm going to create the circle controller at home. So this will be also your assignment for home. So at home you can create any kind of shape you want there. Okay. So now let's duplicate this controller. I'm going to snap it to this joint. and also to this joint. So now I'll change their shapes a little to kind of show that they're different from the other controllers. So let's change this one here. And for this controller, we can also maybe rotate the vertices a bit to make it more aligned with the face. Okay, there we go. So this one can be a mouse controller. And then this one can be the top part controller. So here we can even place it maybe on the top because it will control all of the top part. So something like so. You can also change it a bit so that it wraps more around the geometry. Okay, this should be good for now. You can go at home, you can go crazy and make them all really nice. Okay, so the idea is that it will be moved like so. Now, so we constrained these joints, right? So we can already test how the joints are constrained in these two controllers. We want to parent to this one, so to the last controller here. Okay, and let's also, I don't think this joint is constrained. So let's make sure to constrain this one as well. Constrain and orient. Okay, so now if we are to rotate it, the joint will rotate with it. Now if we rotate all of them, so the whole character moves in the same direction. Now we can also rotate the worm like so, or sideways. Okay. So now we want to decide what to do with these joints. So simple orient constraint won't work for them because we also want them to be translated. So we want to decide whether we want to point constraint and orient constraint them or parent constraint them. So in this case, it actually won't matter that much because the controller and the joint is positioned at the same spot. So we can just do a simple parent constraint because then we just are creating one constraint instead of two. Okay, so let's first constrain the stop joint. Constrain parents. And now we're constraining the bottom one. Constrain parent. All right, so now we can move the top constraint and the joint moves with it, and together with it the jaw and the eyes. And the same thing happens with the bottom controller. And we can also rotate it, and that will open up the jaw. And the same thing with this part. We can rotate it, and the whole top part is going to move with it. All right, so that's kind of the initial setup for the rig. So this is more of a revision of the principles that we talked about last time. So now we can skin this character, and since all of these joints are in the same hierarchy, we can select that hierarchy option and just select the parent. So we can select these joints, then we select the geometry, skin, bind skin, and here, instead of select the joints, we want to bind to joint hierarchy. All the other options should be fine. So now we can bind skin, and now we can test how does it work off the bat. Okay, and for this character, it actually doesn't look too bad. So the main body is moving pretty naturally. So if we are, however, to move the mouth, you will see that this whole part moves. We, however, probably want just the bottom of the mouth to move with this controller. And the same with the top controller. So this whole part moves, and then the eyes kind of go out of the head in a not in a very realistic manner. So what we want to do is we want to change the weighting on these joints. So we would go to skin, paint skin weights, and now you can see all of our hierarchy is here. And because this skeleton was already colorized in the file, it changed the color of these icons on the left. So these icons, they don't mean anything. You can change this color yourself too. So this is just for visual, this is just to separate them visually. Okay, and you can check how the weighting looks on all these joints too. You can change it as well. So here, for example, you might decide that this joint is influencing this part too much. But what we really care about is these two last joints. So this joint is called jaw 01, and this one is skull 01. Okay, so there are multiple ways in which we can approach it. We can paint it with the brush. In this case, however, especially when just starting with a weight painting on a character, it's nicer to block out the weights with selection. At least that's what I prefer to do. So in this case, first I want to add, so first we can add all of the selection, for example, to the top joint. Let's see, so these ones didn't get added. So let's maybe start with them. Okay, let's do something like this. Okay, so let's first assign all of these weights to spine 07, and then separate them into different parts. So these ones will go to spine 07. So now you can see these all changed to white. And also we can select them like so. And again, these can go and be assigned to spine 07. Okay, so now if we're to move this controller, you can see this part is weighted to it, but these controllers now won't do anything. So you can see mesh doesn't move at all. So that's because it's easier kind of to start from scratch rather than when there are already values. So the first thing you might notice that now this part is a bit rigid, so it may be more rigid than you want. In this case, I actually think it works fine, especially in the smoothed version, but we can also smooth it out a bit more. So let's set some keyframes on this controller. So let's go back like so for 10 frames, then down like so for 10 frames, and go to 0. Okay, and now we can, so first we want to make sure that the weights on this joint, so the weights are assigned to this joint to being, let's say 1 here. And now we can lock, yes, so this is also not great, the fact that these have too much values. So let's override those values as well. So we can assign a value of 1 to this joint 0.6. Okay, let's change this to 1 as well. Okay, so now off the bat, this will look even more rigid than before. But what this allows us to do is to smooth it out in between these two joints. So now we can lock all the other joints apart from 0.6 and 0.7. Now we can select these vertex rings, and now we can choose the smooth option, but I'm not sure why doesn't it let me choose it when I have yeah, I'm not sure why is this locked. So usually I would select the rings of vertices, then I would check smooth, and then and then just hit flood. But in case of this geometry, I'm not sure what's happening. I should have probably deleted history on it before before skinning. Oh, let's see. Okay, so now we can smooth, right? So now we have select. Okay, so if we, yeah, okay, so now smoothing works. Okay, I just accidentally selected more more vertex rings than I wanted. Oh, maybe I accidentally had joints selected. So let me hide the joints. Okay, so we are in smooth option. So now we can, now I can see already I hit smooth. So I hit flood, and now it already looks smoother. So now we can continue flooding it, and it will be getting even smoother. So this is the one way in which you can kind of smooth out two areas. So you assign a value of 1 to both of them, and then you smooth out both of them. Okay, in this case, we can do that throughout the whole body, because right now you can see when we move it, there's some values that are assigned here, which is not ideal. So this joint shouldn't be affecting values over there. So what we can do is we can check which joint should have these values. So in this case, let's see, so this is joint 7, this is joint 6, this is joint 5. So all these values should probably belong to joint 5. So we can now just choose paint. But again, I can't switch. I can't switch when I have it selected. Okay, let's unselect. Yeah, so I think, okay, I don't have anything. Don't have these selected now. Select geometry, still off. Yeah, sorry about that. It's not, I'm not familiar with this. Oh, right, so I'm on joint 6, which is locked. Could that be the reason? No, okay, so all our weights are interactive. That's correct. Okay, so let's now go into the object mode. Paint skin, and still they're unselectable. What about now? Yeah, this is an odd issue.
What does the select geometry button do?
Oh, it just selects the geometry to which these joints are weighted. So if we are to unselected and click select geometry, it will select this geometry. Yeah, sorry, I forgot to mention it. But I'm still not sure why can't we switch the paint operation nor the value. This is very odd. Let's select geometry. Okay. Select it here too. Okay. Let's choose this paint skin weights again. Oh, we're in. Yeah, and it doesn't work either. Okay, this is kind of odd. So I'm going to save and restart Maya because I haven't seen this issue before. Joints 0, 1. Save as. And I'm going to restart. Oh, you know what? Could it be because of no, my keyboard layout is fine. Okay, let's take a look. Now let's open it again. Go to downloads. Rigging, skin, paint skin weights. Okay, so now we can switch the options. Yeah, I'm not sure what happened there. All right. So hopefully this will continue. This will continue to work fine. And if not, I'll have to look later into what's causing it. Okay, so let's again see. So right now, spine 7 is controlling a lot of this weight, which should be probably controlled by spine 5 or spine 6. So for now, we can just unlock these two, and I can replace the weights of joint 7 here with 0, or I can add value of 1 to joint 6. So no other joints will be affected. So what this will do is it will just get all that value from joint 7 and place it on joint 6. Like so. So now you can see joint 7 only has this area skinned, this area painted. And we can do that for, so now you can see when we move the head, these parts don't move. Maybe here a bit. So let's make sure to paint this to 1. There we go. Okay, yeah, so now only this part is moving. And you can see even though we painted all of this white, now it changed color, because in reality, we didn't replace all of that value with 1. We just replaced all the value that was of level of joint 7 to joint 6. And we can go further and do that with other joints too. So for example, in this case, joint 5 is controlling, has weight on all of these other joints. That's also probably not something we want. So yeah, so that's why usually when I do weight painting, I just replace all the weights. So I go joint by joint. And so for example, I would flood everything first to be the weight of joint 1. Then I would go to joint 2, assign a value to 1, then smooth in between them, and so on. In this case, however, as I said, so off the bat, it wasn't that bad, so we can keep it and just tweak it a bit like I did now. So replace some values and so on. Okay, and so now the weighting on this part is better because it only affects that crease. Okay. So now, yeah, so you can see the same thing with jaw 01. It has these weights here, which we don't want to be there. So these weights should belong probably to joint 6, right? So we can, what we can do is we can lock everything but jaw 01 and spine 6. And now we can assign these weights to spine 06. Okay. And we don't have to be precise because we just want to replace those kind of rogue vertices that had different weights. Okay. So now you can see jaw 01 doesn't have any values, and skull 01 also doesn't have any values. So now we can start actually working on those two areas. So first, we want to paint all the top part to skull 01 and all the bottom part to jaw 01. Okay. So we can first select this area. So all of this area should probably go to this skull 01. So let's flood all of that. Select this. Now we can also do, oops, wrong one, this one. Oh, wait. Yes, now I don't want these locked. So at least I don't want this one locked. right? Because that's the one we're taking the weight from. Okay, so selecting skull 0, 1, applying the weight of 1 to it. And again, we want to select these vertices from the top. Also apply it to skull 0, 1. The right side doesn't really matter to us because the character is symmetrical, so we can just mirror the weights afterwards. Okay, and now for this part, I'm going to select the vertices from the inside and increase the selection like so. Okay, let's see. Okay, so these ones got selected as well. That's good. So now we can flood. And now there was still some vertices missing here. So we can select them and add that weight here. So this is kind of the blocking stage of the weight painting. So now if we're to move this controller up, you can see that all of this part belongs to this joint on the top, and all of this joint belongs to, so all the weight on all of these vertices belongs to this joint at the bottom. And you can see already the character opens the mouth, but it's not very, it doesn't look very natural. So let's zero out our controller. So here we can create an animation to help us visualize it. Let's delete all the animation here. Now we can have it open up the mouth. So already we can mirror the weight to the right side by going to skin, mirror skin weights. And here we want to choose YZ because that's the plane, and positive to negative. So from positive X, so you can see here, to negative X here. So from characters left to characters right. Okay, so this doesn't look too great. Let's try it from the bind position. There we go. Okay, so now it's more symmetrical. Okay, so even though this is done, you can see this is not very smooth. So we can smooth out this area by, again, so let's go into paint skin weights. So again, we can select, let's hide the joints. So we can select this area. Let's see, it took all of it. It's good. Now let's take a few more vertex lines here. And then we can smooth in between these two joints. So I'm locking all the joints apart from these two, clicking smooth, and now I can flood. Wait, why is this? Oh, I think I forgot to, what we also want to do is we want to assign the weight of 1 to this jaw 0, 1, which I completely forgot to do. Okay. And since that weight right now is on spine 7, we can simply, we can even just paint it as 1 here. All right. So since I'm using a tablet, I think it uses the pressure. Yes, so I'll remove it so that the values are more exact. Here. Okay, so now it's this I don't care about because the other joints are locked, so no values will be assigned there. Okay, so now let's paint all this area inside. All right. So now all of this area is weighted to jaw 01. All right, so again, so we already have this area selected, so that's good. And now we can smooth in between jaw 01 and skull 01. So we're going to hit flood, and you can see these weights are being smoothed out. And as a result, this transition is now more natural, right? And we can increase that selection like so, and smooth further. So now it's an even more more of a kind of an O shape. So actually, let's undo a bit. I think it was a bit too much. So this looks like the most natural here in terms of the mouth. Okay, but now you can see some of these vertices are not being moved quite right. So we can fix that by checking, okay, so jaw 01 right now is affecting them and skull 01 is affecting them too. So skull 01 probably shouldn't be affecting them at all. So we can take all that weight from skull 01 and just have it at the jaw and the spine. Okay, there we go. So now the worm is opening its mouth. So with this part, we can also smooth it out a bit. We can smooth it out here. And now as for all of this section, we can also smooth out, but it's not in between the jaw and the skull, it's in between spine 7 and the skull. So to do that, we'd want to select this. Now, for example, this is how much we want to smooth it, let's say. So now we can again select smooth and now flood. There we go. So now this top part is moving much more naturally. And now let's check the jaw, because usually, so so Animator can do something like this kind of Muppet jaw, but this is not very common. So they will most likely use this controller more. So they will do something like this to open it up, and they also might translate it up and down a bit. Okay, so to make sure that that motion is right, we want to smooth out the weights in between that jaw and the spine 7. So again, to test it, we can actually test both rotation and translation. So this is the rotation. And now this is going to be translation. Okay, oh, and looks like some weight got added here. So let's move it back to spine 7 from the jaw 0, 1. Okay, so we want something like this. So now we can smooth in between jaw 0, 1 and spine 7. And the smoothing will depend on how much do we want this jaw to be affecting the rest of the body. So since this character is not very anatomically correct, right? So it's not like a real worm. A real worm wouldn't have this kind of face. So we would kind of want to think of it in terms of anatomy of a human face. So if this would be a human character, this would be the jaw kind of spreading here. So there should be probably more weight on spine 0, 7 here. So we can even change this all to 1. And now we can smooth this part here. Okay, so now the mouth is opening kind of just a little bit, almost like a bird's mouth, right? Like a beak. Okay, and then when it goes down, this looks pretty natural too. We can smooth it out a bit here though, so that it goes down a bit better. Okay, now we want to mirror the weights. And with mirroring, so sometimes it works well, sometimes it doesn't. So if it doesn't work well for you, you might have to manually go into the other side and change some weight painting there. Okay, so this is the rotation and there's the translation. Okay, so both work well here. So at this point, we can say that the skinning is done. So we can check once again all the other parts, make sure they didn't change. So I'm noticing that there's some values here that we might want to fix. So let's go to paint skin here. See, yes, so skull 01 has these weights, which you probably shouldn't have. So let's add more of those to spine 7. Okay. Now we're checking the top of the skull, so this looks good to me. And then the bottom, let's rotate a bit more. Probably maybe can be smoothed a bit more than this part. It intersects, so we can work on that as well. We can work to make it not intersect. So we can add some more values here. Now for this part, now that I'm looking at it more, if the animator is going to be mostly translating it, we probably want to add more weight there. So there are definitely things that we can improve, but for the most part, we can call it, call the weighting done for now. Also at this stage or before, we would want to rename all the controllers and also lock and hide the attributes that are not going to be used. Again, for the purposes of speed, I'm not going to do it now, but this is something that you want to do at home, as well as change. So we want to change the names of the groups as well, and change the overall presentation of this. So we can create a group for joints. So the main geometry is called warm geogroup. So we can call this warm joint group. So it's always good to follow the convention that is already established, right? And this can be warm controllers. Okay, and then all of them can be in one warm master group. All right, so now that we're happy with the way our character is skinned, we can create some blend shapes for example, facial expressions. So at this point, the only things it can do with the face is open open the mouth, either like that or like so. So we can create some additional expressions for the worm, for example, to smile or to frown, and so on. So in this case, we'll just create the expressions for the mouth. And for your assignment, you have to create at least 3 blend shapes, but you can create as many as you want to create more expressions. So in this case, I'll just create 2. I'll create one for smile and one for frown, and then I'll show you how you can split them into separate parts. Okay, so we want to duplicate the geometry we have. Let's unlock it like so. So same way as with the cube, we can duplicate the geometry of the character and just create blend shapes on the duplicates that we create. So let's make this one into a smile, and you guys can make it way better than I will. My modeling skills are not that great. Now I can't even, there it is. So I'm going to use soft selection to actually let me turn on the mirroring. Was it symmetry settings? Yes, okay. So because I want to model it on both sides. All right, so I'm going to make it go up like so. Rotate it a bit. All right, so this will be the smile expression. And then this one is going to be the frown. Oops. And let's select a couple more vertices here. All right. And there we go, a bit of an uneven edge there. Let's do something like so. And then like so. Okay, so in this case it smiles, and in this case it frowns. So other expressions that you can add for the mouth. So one would be just mouth to the side. So like so, or the mouth closer together like so. Then another thing you can add is kind of this expression for this part and this part. Another thing is cheeks. So they can be puffed cheeks like this, or like cheeks got into the face like so. So those would be the two opposites, and it's good to work with the opposites like that, because then you can connect them to the rig a bit easier. Then you can have, for example, sliders for Animator or controllers on the worm itself. Okay, so now that we have these two expressions, again, these are not great. You guys can do way better job. So we can select now these meshes, select the original, go to deform, blend shape, and let's call them worm blend shapes. Sorry, I'm switching between different keyboard layouts, so so I'm a bit unused to the QWERTY keyboard. Okay. Now let's click create. And if we are to go to Animation Editor's shape editor, you can see the shapes we created. So now the worm frowns, and now the worm smiles. Okay. And you can notice that if we are now to rotate, for example, well, actually, that's not a good example, rotating the head. Let's say we want to open the jaw. So what we would want to now do is when it smiles or frowns, we would want those shapes to be added onto what we already have. However, if right now we're to frown, it kind of closes its mouth. So with rotation, you will see, so if we rotate it down, now it will go back to its original position, right? It will try to blend to this shape. So that's not what we want. And that's because of how different deformers are being placed inside of our inputs, right? So we have our skin cluster and then our blend shapes. And right now, the blend shapes goes above the skin cluster, so it will favor the blend shapes. So it will first calculate the skin cluster and then the blend shapes. So we can change that. If we go to our inputs, so inputs, all inputs. So here we can change their order. So we can place, oh, it doesn't let me. Is it because this is not in the default position? Let's try now. Inputs, all inputs. There. So now we can change the order, close. And so now if we're to rotate or open the worm's mouth, oh, still acting not right. Let's see, maybe inputs, all inputs. I guess it's the tweak as well. Wait, so we want to move this one. And then let's move the tweak here as well. Okay, so how about now? All right, there we go. So that's something that that's more of the shape that we're looking for, right? So now if we are to move the jaw down and move the shape, it will kind of change an expression with the mouth being down. So the joints are driving, joints are being calculated after the blend shapes, the joint deformation. But we can also, instead of doing that, so if we are to delete if we're to delete these blend shapes, so when we're creating the blend shapes at first, we can already avoid that issue by going to advanced settings, and in the formation order, we can choose here where in that input order it's going to be. So if we're to choose pre-deformation, you can see that now blend shape is positioned after the skin cluster. So if we are to now rotate this and change these values, you can see off the bat it works correctly. Okay. And yeah, and so here, now, for example, here I can see that when I'm turning on this blend shape, the T's, for example, are showing, and these vertices don't look quite right. So now we can go to Windows, Animation Editors, Shape Editor, and if you click Edit here, you can modify this blend shape to be good on the rig itself. All right. Any questions so far about this? No? Okay, good. So one other thing you might want to do is to create controllers that are going to control those blend shapes. And also, you might want to separate those blend shapes to the left and the right side. So in order to do that, one thing you could do is you can duplicate these meshes and you could paint. You can paint out, so how we looked at the blend shape painting, you can paint out one side and leave the other and do the same thing for the other one, right? But if you have a lot of shapes, that will be a lot of duplications. So what we can also do, so let's delete the existing blend shape. So we can delete this blend shape. So instead, so we can keep these shapes. We can duplicate this one. And now this will be the shape that will be responsible for separating the sides for left and right. And these will be our expressions which will have to be mirrored. Right, so now what we can do is, let's see, so we want to create blend shapes for this shape. These can be side shapes. Okay, so now this will be the blend shape that will have to have two of them connected, and now we can go in and paint it to the left and the right side. So we can, again, for this case, we can, let's change symmetry to be off. Okay, and this kind of thing you don't need to do at home, so this is just one way of doing it that that I can show you. Okay, so now we can change this to be 0. Yeah, sorry, we actually want to create let me think. So we want to create 2 of these, so 1 for each side, and then connect as many shapes as we want to the 2 of them. Right, so let's actually create 2 here. So then we can connect all of them to this one and all of them to this one. So let's do that. So the form, blend shapes. So let's say this one can be left shapes. This one can be right shapes. So now we can go and do the blend shape painting trick. So we can select this part. Need to paint it. Oh, actually, we want all of them painted by 0. In the center, we can paint to 0.5. And now you can see if we are to change these shapes, so left shapes. Oh wait, did I paint some wrong one? Let's see. Oh, sorry, side shapes. I guess I called them side shapes. Let's see. Okay, so now if there they are. Okay, side shapes. So now if we're to trigger this one or this one, you will see they will only work for one side. In this case, it's the right side. So this one should be the right shape and the other one the left shape. And then for this one, we can paint it in the opposite way, right? And then we can connect both of these to our original shape. And that way we will have it separated to the left and to the right. So we can still then trigger these blend shapes together with these blend shapes, with the side blend shapes, and both of them will work for this character. We can also just keep the side blend shapes on at all time, and then just different blend shapes will be affecting it. So from the right or from the left. But again, for this class, this is not needed. You can just have different blend shapes for the mouth. And then if you want to separate them to the sides, you can just duplicate each one if you want. Okay. Any questions about blend shapes or skinning? No? Okay. So then for next class, what you want to do is to skin the worm, create blend shapes. You want at least 3 blend shapes. You want to create, then you want to create a video that shows the deformations that you made. So make sure to show how all the controllers work and how all the blend shapes also work. Okay, any final questions or comments? No? Okay, good. In that case, I'll see you guys next week.